Hi, my name is Angela Lynn, and this is Lab 1 for Physics 2212, and our project is on the charge of interacting tapes. So the purpose of this lab was to determine the amount of excess charge on a floating tape interacting with another charged tape, and to produce a computational model of those tapes exerting electric force on the other, and use it to estimate the amount of charge necessary to float one tape above the other. The system in this case would be the two charged tapes, and the surroundings being everything else. So for the methods as depicted in this diagram, I took two pieces of tape, roughly 8 inches long, and charged them, and then placed one piece onto two blocks and held the other tape up and recorded the displacement. Here's just some background information. The length of the tape was 8 inches or 0.2 meters, the mass of the tape being 0.2 grams, and the distance between two tapes when one floating above the other would be 0.023 meters. Important formulas included Newton's second law for F equals mg, as well as Coulomb's law for electric force. And so Coulomb's law for electric force, once we set it equal to mg, we can then rework it to get the charge Q. Another important formula is for the magnitude of the electric force, which is just the absolute value of the electric force. Some observations that I made during the lab include that when the two charged U-tapes interact, they repel, and when the U-tape interacts with the surroundings, such as a pen that was first rubbed through the hair, making the pen negative, then it attracts. So a plastic pen is negatively charged. So if a U-tape is positively charged, it will attract, which is what we saw. Now, if the U-tape was neutral, it would still attractively interact with the charged plastic pen, because when you bring the neutral U-tape close to a charged pen, the charge in the pen will induce an opposite charge distribution in the tape and interact. So after interacting with the tape, I confirm that the charge of the tape should be positive. So here's my glow script code for finding the charge of a charged tape. So the absolute value of electric force is equal to Q squared divided by 4 pi E naught times D squared. And this is because the charges we are going to assume are the same. So reworking the equation in glow script, we're able to isolate the charge and square root it to get the single charge of 1.07 times 10 to the negative 8. This is the second part, which is the computational model. And so the deficiency of electrons on a tape, I set it equal to the charge on the piece of tape divided by the charge on an electron. I then calculated how many atoms can fit into one piece of tape using the dimensions of the tape and divided it by the electron count to get the ratio of number of atoms to the number of electrons on one piece. And this is just what the computational model is. For the experiment, we had to make 3 assumptions in order to determine the amount of charge on the floating tape. It was important to treat the tape as if the charge was concentrated at one point, as well as to assume that both pieces of tape had the same amount of charge, just to simplify the formulas which I included in the previous slide. If electrons had a positive charge and protons had a negative charge, then quantitatively the result is still the same, except for the signs of the charges. Also, it was important to limit the amount of handling of the charged tapes as much as possible, because when charged tapes come into contact with other objects in their surroundings, charge displacement can occur, which affects our assumption that the charged tapes share the same charge, and it affects the isolated environment assumed by our equations. So some limitations include that there's no true point charge, and we had to make the assumption that the charges were centered at one point, as well as make the assumption that the two pieces of tape were of equal charges, but man-made error could have played a role when handling the tape, causing accidental charge displacement, making the charges of the tapes unequal. And so the assumptions that we did make to simplify the calculations do not necessarily hold in real life.